Hello friend, welcome to today's class. I'm going to be treating the topic algebra. So I'd like you to fasten your seatbelt as you enjoy the class. To start with, what is algebra? Algebra, I don't know the definition you've been told, but algebra is simply the combination of number and letters. Alright? It's simply the coexistence of numbers and letters. For example, if you see something like 5a, this is an algebraic term. Alright? So something like this is an algebraic term. So algebra is the coming together or the coexistence of both numbers and what? Letters. That's correct. So like you can see, this is 5, this is a number, and this is a, this is a letter. So now let me show you an example of an algebraic term. For example, 3x plus 2. Now what you're seeing right here, 3x plus 2, is an algebraic term. But then I will use this algebraic term to define some terminologies in algebra. One of which is this 3 you're seeing here is called the coefficient. This 3 is called the coefficient. Alright? So 3 is the coefficient of x. Are you with me now? This x you're seeing here right now is called the variable. And this 2 you're seeing here is called constant. Okay, why is it called constant? Constant in the sense that this number here cannot change. It is 2 and it will remain 2. But why is this called variable? Variable because this number here can be any letter, can be any number rather. It can be 2, it can be 1, it can be 3, it can be 5, it can be any number at all. And this 3 is called coefficient because it is the number preceding the variable. I hope you understand that. Okay, so now this expression here, this what you're seeing 3x plus 2 is an expression, and that will take me to algebraic expression. Alright, so let me quickly look at algebraic expression. Now in algebra, we have expression and equation. Alright, but for this class I'm going to be treating algebraic expression while we look at algebraic equation in the next class. Okay, so for example here I have 3x plus 2. This 3x plus 2 you're seeing here is an algebraic expression. It is not an equation. And then if you see something like this, 3x plus 2 equals to, let me say, 7. Okay? 3x plus 2 equals to 7. This is an equation. So let me do this. This is an expression. Alright? Why this is an equation? That's the difference. Why is this guy called equation? Equation because of this equal to sign. Because of this equality sign. Do you get it? Alright. So that is expression and equation. One difference is that the expression cannot be solved. For example, I can't solve for x in this expression. No. The only thing I can do is to simplify an expression. Like this expression now cannot be simplified. But you will see some expressions as we go ahead that can be simplified. But for this one, I can solve this equation. Alright? I can solve for the value of x in this equation. Are you getting me now? That's the difference between expression and equation. For example, 4y, 3x, let's say p over 3, and let me use 2xy. Now, looking at all this, we are to find the coefficient. So let me assume we have a question like find the coefficient of the above. So we have to find the coefficient of each of them. Are we together? What is the coefficient of y? Are you getting me now? The coefficient of y is going to be let me tag them number 1, number 2, number 3, number 4. For the first one, the coefficient of y is 4. For the second one, the coefficient of x is 3, because I told you coefficients are always the number preceding the variable. And then, very interesting, what is the coefficient of p over 3? Correct. You just guessed right. Coefficient of p over 3 here is 1 over 3. Do you get that? And here, the coefficient of xy is 2. That will lead us to the addition and subtraction of algebraic term. But before I do that, I like to lay a little emphasis. If I'm to have, let me say, 5a, for example, okay, 5a is the same as 5 times a. So the binding force between 5 and a is the multiplication. Alright? So this times you're seeing here is the operation. Alright? So we have 5, which is constant. We have a, which is variable. But what is the binding force between two of them? Times. Alright? Multiplication. Now we have p over 3. What is the binding force in this p over 3? We have 1 over, we have p divided by 3. Alright? This p is a variable, this 3 is a constant, and this operation is division. Alright? So let me say this is multiplication, and this is division. Okay. Then that will lead us to addition and subtraction of algebraic term. Let's take, for example, we have a plus a plus a plus a plus a. Now, see this, a plus a plus a plus a, what is it going to give us? Now, this is basically addition, alright? So a plus a, that's 2 a's, 3 a's, 4 a's, 5 a's. So the answer is 5 a's. Basically, we have 5 a's. Do you get it now? So that's just the basic thing about addition and subtraction about the addition of algebraic term. Alright, remember that I told you that 5 times a is 5a. The same thing happens here. A plus a plus a plus a plus a is 5a. They are the same thing. Reason is because multiplication is repeated addition. For example, you say 2 times 3. 2 times 3 will give you 6. You're saying the same thing, that 2 added by itself in 3 places. That's what you mean. So if I do 2 plus 2, 4 plus another 2, 6. So I just got the same answer. So a plus a plus a plus a plus a will give us what? 5a. So I don't want that to confuse you. Alright? Now, let's look at another example. Here we have 4y minus 2y. What is this going to give us? This is subtraction aspect of algebra. This is 4y. This is 2y. Alright? This 4y can subtract 2y because they are both of the same family. And what's the family? Y and y. Do you get it now? So I can say 4y minus 2y is just basically saying that 4 minus 2. So 4 minus 2 is going to give me what? 2y. Do you get it now? So my answer is 2y. At the same time, if you look at it like this, 3x minus 2y. Now, what is this 3x minus 2y going to give me? It's not going to give me any answer. Reason is because x and y cannot subtract each other because they are not of the same family. Do you get it now? This is x, this is y, so it cannot work. The only thing I can do here is to leave the answer like this. and say the answer will still give me 3x minus 2y. There's nothing I can do to it. I can't change anything. The only thing I might be able to do, if the constants, or sorry, if the coefficients are factorizable. So let's go a little bit more advanced. For example, we have 4v minus 3y plus 2v plus 5y. Alright? So this is what we have. How are we going to solve this exactly? There's something known as collect-like terms. This is collect-like terms. Alright? But before I solve anything, I'd like you to understand that each of these algebraic terms, the sign in front of them is owned by the term. For example, 3y is what owns this minus, alright? So this minus 3y. 2v is what owns this plus, okay? And this plus is owned by this 5y. Do you get it now? So we're going to look for the ones that are of the same family, that's the like terms. Here we have 4v and 2v. They are of the same family of v and v. So they are together. Then 3y and 5y, they are of the same family of y and y. Okay? So they are also what? Together. Now, then it's going to lead us to saying that 4v, so we're going to rearrange them now. 4v plus 2v minus 3y plus 5y. Do you see now? So I've been able to rearrange them according to their family. This is the family of v's and this is the family of y's. Alright? So 4v plus 2v is going to give us, it's just like saying 4 plus 2. Alright? Then 4v plus 2v is going to give us 6v. Then I want you to note that minus, whenever you see a negative sign, it simply means that you are owing. Why? Positive sign means you have. So now, let me assume that I'm owing somebody 3 pencils. So, don't forget, negative is what? Owing. So, I'm owing somebody 3 pencils. And now, I have 5 pencils. So, if I return the 3 pencils I'm owing, how many pencils do I have left? Okay, that's correct. You just got it right. The pencils I'm going to have left will be what? 2. Now, am I having the pencil or I'm still owing the pencil? You see that I'm having the pencil. I have the pencil. But if this happens to be the other way around, it's going to be negative. But for the sake of this question, I have it as what? Plus 2y. Now, I've gotten to this junction. What exactly am I going to do with solving this question? Should I just leave it like this? Yes, if I leave it like this, it's not like I'm wrong, but I can still do something to this question. That means I can still simplify it further. Okay, so what can I do here? V and y are not of the same family. So obviously I can't do anything about that. But 6 and 2 looks like something can be done to the both sides of this question. What can be done? I can factorize out 2 from here and also factorize out 2 from here. So 2 is common to both sides. Can I see 2 in 6? Yes, because 6 is a multiple of what? 2. 2 times 3 is going to give me what? 6. So I say that 2 is common here. I can see 2. And if I remove 2 from this 6, I'm left with what? 3. So that's 3v plus, if I remove 2 from this 2y, what do I have? I'm left with 1. Okay? 1 times y is the same as what? Y. So I have it as 2 in bracket 3v plus y. Do you get it now? Alright, let me also look at another example. So another example says simplify the let me say simplify the question, okay? Now we have something like 4y plus 3v minus 2j, okay? Plus 5v equals to 7y minus 5j. Okay, so this is the question I have now, and I'm going to solve this question. So in solving this question, what do I need to do? Don't forget, I collect like terms. Okay? So in collecting the like terms, I'm going to bring the terms that are similar together, okay, while I take the other ones too on the same side. So what are the terms that are similar here? I can see 4y and 7y. I can see 3v and 5v, and I can see minus 2j and minus 5j. So those are the terms I'm going to bring together. Okay, but I'd like to emphasize something very shortly, that whenever a sign is going over the equality sign, for example, I have equal to, if plus is going over the equal to sign to the other side, alright, I will have what? Minus. And if minus is going over the equal to sign, I will have what? Plus. Do you get it now? So if minus is going over the equal to sign, it changes the sign to the other one. Now let's bring the families together. So here we have 4y. If this 7 here, 7y is going to the other side, what is it going to be? Here we don't have any sign in front of it. But then whenever you see a natural number, the sign in front of that natural number is always positive. If I have 7, 7 is the same as plus 7. Okay? But I can't say 7 is the same as minus 7. No, it is not. Alright? So, but whenever you see 7, 7 is the same as what? Plus 7. If it's 2, it's the same as plus 2. So here we have 7 ordinarily. That means the sign in front of it is what? Plus. So when you are taking it to the other side, crossing the equality sign is going to change what? It's going to change and become minus 7. Okay. Then I have 3y, 3v, and I'm bringing in plus 5v. Because it's not crossing over any equal to sign. They are on the same side, alright? It's not crossing over any equal to sign. It remains plus 5v. Now, minus 2j. If I'm taking this minus 5 over the equality sign, what's it going to become? It becomes plus 5j. And that equals to 0. Because by the time I've moved this and I've moved this one, there will be nothing on this right hand side, and that is equals to what? 0. Alright, so I have 4 pencils and I'm to give somebody 7 pencils. If I give the 4 pencils, how many am I still owing? How much? I'm still owing 3. So I have minus 3y. Alright? Then I have 3v plus 5v. I have 3 pencils and I still just got another 3 pencils, and that's going to give me what? 8 pencils. Then I'm owing 2 pencils and I just have 5 pencils. So if I return the 2 pencils I'm owing, I'm going to have how many now? 3. So that gives me what? 3j equals to 0. Now, can I still simplify this further? Let me check. This is 3, this is 8, this is 3. Can 3 go in 8? No. Are you seeing it now? Therefore, this is my what? Final answer.